Hello, scholars. Today we're going to cover one of the trickiest discounted cash flow questions you can come across. So let's get to work. Here's the question. You will receive 11 annual payments of $25,500. The first payment will be received 5 years from today, and the interest rate is 5.4%. What is the value of the payment today? So before we get too excited, I just want to draw out what's happening. If T0 today is here on a timeline, we have 4 years where nothing is going on. There are no payments or anything. We get a payment at time 5 that will continue for 11 periods, and our payment is $25,500. So there we go. This is actually a two-part question. It looks like one question, but there are really two key components. This component here is an annuity. We have fixed cash flows of $25,500 for finite time, 11 payments. That's how I know it's an annuity. This happens for 11 periods. So the first component here, we compute the present value of an annuity. If you assume this is an ordinary annuity and the payment starts at time 5, you'll be solving for the value at time 4. And then you bring this figure home by discounting it 4 periods to solve for the present value today. So here's your present value today. If we start with just the annuity, the equation you're looking at is the payment times 1 less 1 over 1 plus your discount rate to time over rate. This is the present value of the annuity. Now, if the annuity starts at time 5, this component will tell you the present value of the annuity at time 4. So then to discount that, you need to discount it as a single cash flow using a discount factor of 1 plus R to the T. So once we fill all this out, your annuity is $25,500 times 1 less 1 over 1 with R is 1.054 to the 11th. You get 11 payments of $25,500. And then this we treat as a single cash flow and need to discount 4 periods. That's the key issue. When you use the ordinary annuity, it tells you the value of the cash flow at the beginning of the period, which is 1 period essentially before the cash flow starts. So then we discount this at 1.054 to the 4th. So I'm going to do this several ways. I'm showing you the formula approach first, but then we'll do a couple other ways to hopefully help you. 1.054 to the power of, so you press Y to the X, and then you prompt 11 in there. That is this term, 1.054 to the 11th. We invert it by pressing 1 over X. It has a negative in front of it. Add 1 to that. That's your numerator in the hard brackets. Divide by that discount rate of 0.54. And that is your annuity discount factor. Multiply that by the 25,500. This is the value of that annuity at time 4. And I think that makes this question tricky. Is it's commonly thought that that's the value at time 5. But if the payment is received at time 5, using the ordinary annuity equation will tell you the value at time 4. So this now we treat as a single cash flow. I'm going to save that number by pressing store 1. STO is right here on the left-hand side, store 1. And I'm going to compute this term in red, my discount factor for a single cash flow. That's 1.054, Y to the X of 4 equals, now that's my denominator. If I take the inverse of that, now I have the factor and I multiply that by the number I saved. So I press recall RCL 1, and we find out that this annuity today is worth $168,000. So let me type that here. PV0 is $168,000 $880.05. So let me show you a couple other ways, and let me just double click into how we got there. This had two components. The question may not have looked like it, but there were really two things going on. You had an annuity, and then we had to discount a single cash flow. So I put those equations here, the present value of an ordinary annuity. Notice C, the payment, if it occurs at the end of the period, then the equation will give you the value 1 period before the payment starts. This is what made the question so difficult, is this wasn't received in 1 year, but it was received in 5 years, and it kept going for 11 times. So if your payment starts at time 5, this equation will give you the value 1 period before that. So it'll give you the value at time 4. So then we take that value at time 4, and we need to discount it 4 periods here. That's why these had two different equations, and there's two different parts. Now let me show you that again using the formulaic approach. We had an annuity, so we said the present value today is that annuity of $25,500 times 1 less 1 over 1054 to the 11th. We're valuing the annuity in this component here over 0.054. And if this payment starts at time 5 right here, then this will tell you, this whole term will give you the value, the present value at time equals 4. So instead of focusing on present value, we'll just call it value at time 4. And then this term, this entire piece here, needs to get discounted 4 periods. So you can just multiply that by 1 over 1054 to the 4th. And here is the most common mistake here, is treating that as a 5 as opposed to a 4. Let's try it again. I'm going to show you another approach here on the cash flow function. If you're allowed to use a financial calculator, this can be a very convenient tool. But I think when you get questions that have more than one step with DCF, it's extremely helpful to draw out a timeline. We have 4 years where there are no cash flows occurring. And then at time 5, for 11 periods, you're getting a cash flow of $25,500. So one way we could do this is recognize that, hey, there's no cash flow here. So cash flow 0 is 0 today. And then the next stream of cash flows, we'll call it cash flow stream 1, is 0. And you have a frequency of 4. And then your next stream of cash flows, cash flow 2, is 25,500 for a frequency of 11. So that's the key part of the issue, is recognizing a timeline, timing, risk, and magnitude. And let's show you how to do it, the cash flow approach. You press this cash flow button here on the second row, second clear work, that will zero everything out. Cash flow 0, there's no cash flow today. So I'm going to scroll down on the top row. My first stream of cash flow is 0. The frequency of that is 4. Enter, and then down. My second stream of cash flows is 25,500. Enter, down, and we have a frequency there of 11. And then we compute the net present value. So computes up here in the upper left, NPV on the second row. And we have prompted the calculator for timing and magnitude. It now needs risk. Timing, risk, and magnitude are the key to valuing just about any financial asset. Our risk here is 5.4. Your calculator knows that this is a percent. You use a formula, you move the decimal. If you're using the financial calculator, you can just enter 5.4% there. Enter, down, and then compute. Notice we're getting the same result as we did before, 168,080. So the calculator is not magic, it is just math. You can do this. Now, there's another approach too we could solve. If you're used to this row of 5 buttons, NIY, PV, payment, and FV, that will also get you there. It's still a 2-step approach where if you outline this on a timeline, you can see that this is the portion of an annuity. How did I know this is an annuity? Well, they're fixed cash flows for finite time. The keywords you're looking for are anything that says payment or per year or per month. So you have fixed time and you have fixed cash flow and finite time. That's the two components there to your annuity. So if you want to find the value using these 5 buttons, it is still a 2-step approach. Your payments, PMT, is 25,500. Your relevant discount rate is 5.4%. There is no future value. You are just valuing the 11 payments right now. There's no additional lump sum at the end of that. So N is 11. And you compute for your PV. So again, here's my row here. It's the third row from the top on the financial calculator, 25,500. That is your payment with 0 future value. 5.4 is your IY. N is 11. So you're pressing 11, then N, and then you're going to compute for the one that's missing. So up here on the top, CPT compute, PV. Be careful here. This is the value of the cash flows at time 4, because your calculator default is to give you an ordinary annuity. So then you're left valuing this as 207, 207, 433, and 37. Now you can ignore this stream as you value the second step. Now you're back to dealing with a single cash flow with no payments along the way. So here we treat this number in our calculator of 207,000, the value of the annuity at time 4 is your future value with no other payments along the way. So I'm going to put 0 in for payment. My discount rate is still 5.4 is your IY. And here's the key. It is 4 periods of discounting, not 5. And then you compute your present value and you see, ignore this negative, and you still get the same answer of $168,080.05. This is a very tricky question. I think the hard part of it is knowing when that first payment occurs. And then if you're applying an ordinary annuity process to that, an ordinary annuity assumes the cash flow occurs at the end of the period, which is exactly equivalent to the beginning of the next period. So here, if the cash flow starts at time 5, using the ordinary annuity will give you value at time 4 that then needs to be discounted 4 periods as opposed to 5. So this is a very common mistake. I hope this helped you learn it. If you need any more help, please let me know. I'd be delighted to help you.